because it has a higher frequency. So the shorter the thing that's vibrating, whether it's a pipe and a column of air or a string, the shorter the thing, the higher the pitch. Ava, you hear two musical notes. They both have the same pitch, but the first is louder than the second. This is very similar to a test question. You compare the sound waves that produce the sounds. What aspect would be the same? Wavelength, frequency, speed, or amplitude?
Frequency and speed.
Frequency is the same. And what does frequency cause in a sound wave? It's not up there anymore. Pitch. Frequency is causing pitch. Why is speed the same? So think of this problem. The speed of sound in air. Does speed change if you're oscillating the same temperature air? So velocity or speed, they don't change because it's the same air, same temperature. And what would be different about these waves? The amplitude is different. So, which wave would have a bigger amplitude, the louder or the softer? Louder one has a bigger amplitude. Big amplitude is loud noise. And that's why a super loud noise will break your eardrum, because that big amplitude will really push your eardrum in, because remember the amplitude is oscillating or parallel to the direction of travel, so it's really going to poke in your eardrum. So Elise, the horn on your neighbor's car is stuck, so it blows constantly. You watch your neighbor get into the car and drive away from you, heading to the nearest garage. If you listen to the pitch of the horn from the time the neighbor starts driving until they're out of sight, what will happen to the pitch? It'll get lower. The pitch is going to decrease or get lower. And it's gone. So it's like our bug traveling, right? You're getting those back and spread out waves. So when a car is moving away from you, it'll sound lower. When it's moving towards you, it will sound higher. And because motion is relative, like you guys learned before, it doesn't matter if you're biking toward a stationary car or away from a stationary car, whether the horn's moving or you're moving, as long as you're moving relative to each other, getting closer makes a higher pitch, getting further makes a lower pitch. Bethany, here we go. You are riding a bicycle toward a stationary police car whose siren is blaring. Will the pitch be lower, higher, or the same? Higher.
Because we're moving
toward it. Okay, I get it. Wasn't
the way they word the question is a little weird.
Really badly
I
worded.
thought it was supposed to be farther, so yeah, it's weird the way
because it says when you actually stop your bicycle. Well, when you stop your bicycle, you would hear the actual pitch.
Yeah.
But that's not what it's asking. I just had to read it twice before I got it. And Lily, you are standing near an interstate highway trying to talk on your phone, and you've raised your voice, so you're speaking at 80 decibels. The sound of the traffic on the highway is 100 decibels. How much larger is the intensity of the traffic sound compared to your voice?
So what you do is you do 80 decibels over 1 times 0.1 bells over 1 decibel, which equals 80 bells. And then you do that again with 100 decibels over 1 times 0.1 bell over 1. And that equals 10. And the difference between those two. And then you do 10 times 10 equals 100. 100. So it's 100 times larger.
Yes, it is 100 times larger. So will you come write that on the board for us? And
The whole process?
yes, if you write the whole thing up, then it might. So there are a couple of ways that you can think to approach these decibel problems. Remember that decibels, every 10 decibels, you're getting 10 times louder. Okay? And remember that 10 times louder is not like adding 10, adding 10, adding 10. It's multiplying by 10, multiplying by 10, multiplying by 10. So what Lily does is she converts decibels to bells.
And then this would be 10 times 10 equals 100 times 1.
Okay, so for every 1 bell for 10 decibels, you get 10 times louder. So you go from 8, you go to 9, you go to 10. So you have 2 groups, and that's 2 10 times 10s. So you can convert to bells, am I in the way?
Oh,
or
no.
you can just remember that for every 10 decibels, you multiply by 10, right? So you go from 80 to 90, you multiply by 10. You go from 90 to 100, you multiply by 10 again, you get 100 times louder. And Chris, an amplifier can magnify the intensity of sound waves by a factor of 1,000. If a 30 decibel sound is fed in, how many decibels will come out?
30,000?
30,000. 30,000 decibels isn't even like on the scale. So, okay, so if you have 1,000, like the speaker is making it 1,000 times louder, how many groups of 10 is that? 3 groups of 10, because 1,000 is 10 times 10 times 10, right? Which is 10 cubed. Okay, so if I have 10 groups here, then just like what Lily did, I would get 3 bells louder, right? So it tells me I start out at 30 decibels, right?
Oh, and then you have to convert it.
Right, so it starts out at 30 decibels, which is 3 bells. So I get 1, 2, 3 bells louder, right? So 60 decibels, right? So we've gone 3, we started out at 3 bells. We add a bell for every 10 times that it gets louder. Since it gets 1,000 times louder, that's 3 groups of 10 times, so it's 3 bells added on. So let's make up another problem. I'm going to make up a problem, hold on. Let's see.
So it's 60 decibels.
Yeah, 60 is the answer to that one. You raise your voice 30 decibel. No, not 30. I don't want 30. 50 decibels to be heard. Your
Decibel.
yeah, like you know in the metric scale you have like kilogram and then you have gram and then you have milligram and then there's a bunch of stuff in between there that nobody ever uses. Deci is one of those things. There is a deca too. The metric scale, listen, the metric scale goes thusly: kilogram, hectogram, decagram, and then gram, and then decigram,
So
centigram.
decigram is 10 lower, decagram is 10 higher.
Yes, and they capitalize these guys and don't capitalize those guys just to try to tell the difference.
Gotcha. So that's why the D in decibel is lowercase.
Yes, and the B probably should be lowercase too, but I'm trying to like emphasize the little b.
Gotcha.
Right. That's just a metric conversion, and you guys have done a lot of that. So I hope classes aren't like over and nobody rang the bell at me. But
We have almost 10
okay,
minutes.
try this problem in the next couple minutes, and then we'll talk about it. The one up there. Do it, and then talk to your neighbor.
I'm guessing camera off.
Yeah. It's